unit digit of the different numbers. How do we categorize the numbers? Unit digit. So the first category of the numbers are 0, 1, 5, 6. So what is the logic for this? The last digit of all these numbers which ends with 0, 1, 5, 6 will have the same digit, right? So the next category of the numbers are 4 and 9. So what is the logic for this? So we'll check that power, whether it is even or odd. Okay. So the next one is 2, 3, 7, 8. What is the logic for the numbers? Powered by 4. And we take the remainder. If the remainder is 1, then we take the 2 power or 3 power 1 or 7 power 1, 8 power 1. So remainder 2 means that we take the power 2, 2 square. And if the remainder is 3, then we directly take the 2 cube. If the remainder is 0, then we will take that power 4. Okay. Now you write a problem. Find the unit digit of this expression. And we know the logic, right? So the numbers which ends with 2, 3, 7, 8 or 4, 9. So rather than taking the numbers separately, so the whole number is given, like, so this is the complete mathematical expression. And you take the individual numbers. First you take that 23 to the power of 451. What is the unit digit of the number? So similarly you find out for this one and this one and this one. So first you tell me for the number 23 to the power of 451. What is the unit digit of this number? So what is the logic? 23. So the number ends with which number? 3. So then what is the logic we apply? Power divided by 4. Power divided by 4 means that what is the remainder? Remainder. 3 is the remainder. So when 3 is the remainder, then final answer is what? 3 cube. So this is not 2. This is 3. So when you are taking for the number 2, then you take the 2 powers. But now the number ends with 3, right? So now we take the 3 power. So since the remainder is 3, so 3 cube is your value. 3 cube value is how much? 27. So what is the unit digit? 7. Now you take that number 2. So here 2 is here, 2 is there. So divide the last 2 digits with 4. What is the remainder we'll get? What is the remainder? First you tell me that remainder. 31 divided by 4. 4 7 is 28. So the remainder is what? 3. So if the remainder is 3, so what is the base value here? 2. So which means that we will take 2 cube value. So 2 cube value is how much? 8. And similarly now this number ends with which number? 5. So 5 means that same number will get. Okay, this number ends with 7. Again, what is the logic? Divide with 4. What is the remainder we get? 42 by 4 means that remainder is what? 2. So 2 means that here the unit digit is 7. We will take that 7 square. 7 square is how much? 49. 49 means that 9. Now you add these numbers. 7 plus 8 is 15. 15 plus 5 is 20. 20 plus 9 means that 29. 29 means that what is the unit digit? 9 is the unit digit. Okay. So we have the numbers ends with 2, 3, 7, 8 will have the logic of what? Divide the power with 4 and then take the remainder. That power will be taken as the final unit digit. Okay. Note down this one. We will do one more problem. Find the unit digit of this expression. You know the concept, right? So first 3. What is the logic for 3? Divide the power 2, 3, 7, 8. So 2, 3, 7, 8. Divide the power with 4. 56 divide with 4. What is the remainder we'll get? R means that remainder. 0 is the remainder. If 0 is remainder, then we take the power is what? 4. Okay. So if the remainder is 1, then we take that power 1. If the remainder is 2, we will take the power 2. Remainder 3, 3. Only if we get the remainder 0, then we take power 4. So 3 power 4. Okay. So now what? So we will take 3 power 4. What is 3 power 4 value? 81. Okay. So 3 power 4 value means that 81. Or at least you know that 3 power 4 can be written. So if you don't know the power 4 values, you can simply write it as 3 square into 3 square, right? You know the values of squares, right? So 3 square means that 9 into 9 is 81. So what is the unit digit of this expression? 1. Now this number ends with what? 4. 4 and 9, what is the logic? Powers. So what is this power? Even or odd? Odd number. When odd number is there in the power, we take 4 power 1. Even number means that no need to by heart it. So even number means that you take 4 square. Odd number means that power 1. So here 49 is what? Which number? Odd number. So 4 power 1 means that what? 4. Next 6. 6 means that again we will get the same number 6. Here again we have that number 4. 4 means that what is the power? Is it even number or odd number? Odd number. Odd number means that 4 to the power of 1 will be taken. So tell me the final answer. 1 plus 4 is 5. 5 plus 6 is 11. 11 plus 4 is what? 15. 15 means that we want the unit digit of the number. Okay. So what is the unit digit of the number? 5 is the unit digit of the number. Okay. Just remember the logics. Okay. You tell me one by one. So 4 is here. 4 means that we look at the power. Power is what? 68. 68 is which number? Even number. Even number means that what is the unit digit? We'll take 4 square. 4 square means that 6. Next, this number ends with 9. 9 means that again the logic is what? Power. We'll check the power. Power, which number it is? Even number. Even number means that 9 square. 9 square, which means that 81 will take 1. Now it ends with 8. 2, 3, 7, 8. So divide the power with 4. What is the remainder? Remainder is 1. So 8 to the power of 1 means that 8. The last number is what? 6. 6 means that again we'll get the same number. Okay, so what is the value? Final value? 6 plus 1, 7. 7 plus 8 is 15. 15 plus 6 means that 21. 21 means that what is the unit digit? 1. And what are the points you need to remember in the factorial numbers? After 5 factorial, all the numbers ends with 0. Next point, except 1 factorial, all other factorial numbers are even numbers. Okay. So find the unit digit of this expression 1 factorial plus 2 factorial plus 3 factorial plus 4 factorial till 100 factorial. Till 100 factorial. For factorial related things, I already told you the concepts behind that. The most important logic we are applying in the factorial numbers. So it is a very big number, like when you add these numbers 1 factorial, 2 factorial, 3 factorial, 4 factorial, 5 factorial, 6 factorial up to 100 factorial. Every number ends with which number? 0. Okay, so 5 factorial ends with 0, 6 factorial ends with 0, 7 factorial ends with 0. So every number ends with what? Zeros only, right? See, 1 factorial value is what? 1. So we are finding out the unit digit. I already told you that when you are finding out the unit digit, so we don't mind about the remaining digits. Only we'll concentrate on the unit digit only. Okay, so 1 factorial value is 1. 2 factorial value is what? 2. 3 factorial means that? You know that 3 factorial means that what? 3 into 2 into 1. So what is the value? 6. Next 4 factorial value means that what? 24. 24 means that we take that only unit digit. We are taking only unit digit. The remaining digits are not important. Next 5 factorial. So what is the unit digit of 5 factorial? 0. 6 factorial, 0. 7 factorial till 100 factorial. So the problem would be given for, of course, 1000 factorial, any number factorial. As you know that, so from 5 factorial onwards, all the numbers ends with 0. So it doesn't mind that what the factorial numbers are given to us. When you are finding out the unit digit of the numbers, only we take the numbers till what? 4 factorial. Okay. So the rest of the numbers factorial, any number can be given. So only we'll consider these values. So then what is the value? So 4 plus 6 is 10, 10 plus 2 is 12, 12 plus 1 is what? 13. 13 means that it ends with what? 3. It ends with 3, right? So from 4 factorial, from 5 factorial onwards, every number ends with 0. For every number, the unit digit is what? 0. Okay. So irrespective of the given problem. Is it clear? Yes. Okay. So now we'll do the next one. So that is previous year problem. CSAT previous year problem. Find the unit digit of 1 factorial to the power of 1 factorial, 2 factorial to the power of 2 factorial plus 3 factorial to the power of 3 factorial. So till 100 factorial to the power of 100 factorial. Any problem related to the factorial is asked, just only you remember these points. From 5 factorial onwards, every factorial number ends with 0, and except 1 factorial, every factorial number is an even number. And 4 factorial onwards, if you divide any factorial number with 4, we will get the remainder 0. So these are enough for factorial numbers. By applying that logic, you tell me the answer. 7. See, when you are finding out the unit digit of the number, so remaining digits are not required. Only concentrate on the unit digit of the number. Only you take the unit digit of the number. As you know that from 5 factorial onwards, it doesn't matter. So whatever the power we have, that all the numbers ends with 0 only. So we don't need to consider the remaining numbers. Only the main numbers what we require is 1 to 4 factorial. 1 factorial means that what is the value of 1 factorial means that 1? 1. So 1 to the power of 1 only. So next 2 factorial means that what is the value? 2 factorial, 2 into 1 is 2. So 2 to the power of 2. 3 factorial value? 6. 6 to the power of 6. Next 4 factorial value is what? 24. 4 into 3 into 2 into 1 means that 24. But when we are finding out the unit digit of the number, we take only unit digit. So 4 to the power of 24. And from 5 factorial onwards, so it doesn't matter that what is the power. So from 5 factorial onwards, no matter how big the power is, the unit digit of the number is always 0. So now you tell me that from this number onwards, what is the unit digit of these numbers? 0 only, right? So 0 any number of times if you add, you will get 0 only. So which means that we will consider only these values. 1 to the power of 1 means that 1, 2 square means that 4, 6 to the power of 6. By the way, what is the logic for 6? 6 only. Okay, now the number ends with 4. What is the logic for 4? Power. Power, is it an even number or odd number? Even number. Even number means that 4 square 6. Now, so 1 plus 4 is 5, 5 plus 6 is 11, 11 plus 6 is what? 17. 17 means that what is the unit digit? 7. Okay, so answer is 7. Yes, it's 7. So this is how we find out the unit digit of the numbers. Okay, so factorial related problems and also the numbers ends with different digits. So the numbers which we categorized is 0, 1, 5, 6 is one category of the numbers, 4 and 9. So we'll check the power whether it is even or odd. The next category of the numbers are what? 2, 3, 7, 8. So divide the power with 4, take the remainder. Okay. The next concept is factors or divisors. And this is another important concept in number system. So factors or divisors. Okay. So what is meant by factor? Factor means that if any number is divisible by different numbers, those numbers are called factors. 8, 12, 24. Okay. So what are the problems related to the factors we have? Questions are like how many factors are there for a number, or how many even factors are there, odd factors are there, and also so how many ways that we write a product of two numbers. So likewise we have the numbers. Okay, coming to this one, so 1, 2, 3, 4, 6, 8, 12, 24. So these are the factors. What we call these are factors. Suppose if I ask you that how many factors are there for 24? So how many factors we have? 1, 2, 3, 4, 5, 6, 7, 8. Since 24 is a simple number, a small number, we can able to write all the factors. But suppose if I ask you what is the number of factors for 2500? So if I ask you the numbers, then you can't able to write all the factors of the number, right? So now we use a method to find out the number of factors. The first one is number of factors, finding the number of factors. And this was asked 2-3 times in the previous year paper. So directly how many number of factors are there for a number, or how many divisors. Factors or divisors, both are same, right? Number of factors for a given number. I'll start with 24. Okay, without writing this number as a product of different numbers, without writing all these factors, how do we find out? So to find out any application related factors are asked, the first thing we have to do is, so when the word factor is given in the problem, the immediate thing you have to do for any problem is, any complicated problem or any easy problem related to this, the first thing is write the given number as a product of prime number. The immediate thing you need to do is write the number as a product of prime numbers, which means that suppose if you take 24, how can you write 24 as a product of prime numbers? Product of prime numbers. 24, how do you, suppose if you write the 24, how do you break it as a product of different numbers? Tell me one number, one way that how we write 24 as a product of two numbers. 24, 3 8s or something like that, right? So here I am saying that the numbers what you are writing as a product of numbers, that must be the prime numbers only. So anyway, 3 is a prime number, right? But 8 is not a prime number. How do you write 8 as a product, prime number product? 8 means the 2 cube, right? 2 is a prime number. So first we need to write the given number as a product of prime numbers. Okay. So there are two ways. One is if you are good at the calculation and the tables, then immediately you can just think of some numbers product. So you can able to write that prime numbers product. Otherwise, there is a method to write the number as a product of prime numbers. That is, you take the number, okay, divide with the different prime numbers. Now you take that. So you can take that number can be divided with any prime number. 24 is divided by which prime number? Perfectly divisible. 24 is divisible by which number? 2. Prime number only. You tell me the prime number only. 2, 12 are 24. Next, again this 12 is divisible by which prime number? 2 or 3, your choice. And finally, so when you write the product, you will get the same numbers only. So order is not important. You can take 2 first or later you can take 2. That's your choice. So 2 6. Next is what? 2 3. So which means that what are the numbers we are using? These numbers. So 2 cube. 2 is using for 3 times and this number is 3. Okay. So 2 cube into 3 power 1. Okay. Alright. 2 cube into 3 power 1. You can write in any way like 2 cube into 3 power 1 or 3 power 1 into 2 cube. And after doing that, so number of factors is, when you are finding out the number of factors, add +1 to each power. Okay, add +1 to each power. What is the power of 2 here? 3. Add +1. And what is the power of 1 here? Power of 3 here? 1. So 1 plus 1. So 3 plus 1 is what? 4 into 1 plus 1 is what? 2. 4 into 2 is what? 8. Okay. If you want to find out the divisors, number of divisors or factors of any number, first write the number as a product of different prime numbers. And after writing the number as a product of prime numbers, add +1 to each power. Okay. Let's take another example. Suppose if I take the 240. One way is you can just divide the number 24 into 10. I mean that. So whatever the idea you get, right, you can break it like that. Or otherwise you can go by this method. I'll show you both the methods. So first of all, tell me that how you can break this number 240. What is the immediate idea comes to your mind? 24 into 10. Suppose if you get this one, 24 into 10. Now you tell me that 24 can be written as what? How do you again break this 24? Because 24 is not a prime number, right? So 24, how do you break it as a product of prime number? 3 8s are 24, right? The immediate idea comes to our mind. So 3 8s means that 3 into 8 is not a prime number, right? 8 can be written as what? 2 cube. This is one thing. And then 10 can be written as what? 2 into 5. Don't tell me 10 into 1 again. Okay. So 2 into 5, right? So now tell me that what are the 2 powers? 2 power 3 into 2 power 1 means that 2 power 4. Okay. Bases are same means that powers must be added. 2 power 4 into 3 power 1 into 5 power 1. Okay. So in this way we can break the number as a product of prime number. Or otherwise you can take the 240 like this. This is a long way. So you can divide like 2 120s. You can divide like this method. You can divide with any prime number. Okay. So 2 30s, 2 15s, and then 3 5s. Okay. So 2 power 4 into 3 into 5. 2 power 4 into 3 into 5. Either you can go it in this way or this way. After that, number of factors is equal to what? Number of factors power plus 1. 4 plus 1 is what? 5. 1 plus 1, 2. So again 1 plus 1, 2. Okay, so 5 2s are 10, 10 2s are 20. So the number of factors is what? Total number of factors is 20. Okay, you understand this one. So 2 power 4 into 3 power 1 into 5 power 1. So after getting that prime numbers product, so you have the powers, right? First you write the prime numbers product and after that you have the powers. Add +1 to each power. Here 4, 4 plus 1, 5. 1 plus 1, 2, 1 plus 1, 2. 5 into 2 into 2. 5 2s are 10, 10 2s are 20. Okay, right, let's take another example. 520, tell me the number of factors for 520. So again you can use two methods, like either you can break the numbers or you can go by the long division method. So 520 means that 52 into 10. Okay, suppose if you get the immediate idea is 52 into 10. Then how do we write that 52? So again, if you don't know the 52 numbers, you can go with this. Okay, so 226 is 213. So if you are good at tables like 13 4s are 52, immediately we can write it. So even after breaking like this, if you don't know that which value you need to write, that you can divide like this. 52 divide with 2, so 226, then 213. 13 is a prime number, right? So what is this number? 2 square into 13. And similarly 10 can be written as 2 into 5. So what is the final number? 2 cube into 5 into 13. Okay, so 2 cube into 5 into 13. So the number of factors is equal to what? Number of factors or divisors. So add plus 1 to each power. Okay, so 3 plus 1 is what? 4. I am directly writing the values. So again, power is 1. 1 plus 1 is 2. Here again, power 1. 13 power 1. 1 plus 1 is what? 2. 4 2s are 8. 8 2s are 16. So the number of factors is 16. Okay, for any problem, first you need to write it in this way. Prime numbers product. The numbers must be the prime numbers product only. And then, so we take the direct power plus 1. Let's take another example. Number of factors of the next one. Find the total number of factors of the number. Number is given in this way. Find the total number of factors of this number. So this is 2 power 5 into 3 power 6. And we need to first check that numbers, these numbers, whether they are prime numbers or not. 4 is not a prime number. How do you write it as a prime number product? 4, 2 square. So 2 square whole square. Next 10 means that 2 into 5 whole to the power of 6. Now if you write values 3 power 6, 2 power 2 into 2 means that 2 power 4. Now this would be 2 power 6, 5 power 6. So now if you add the powers of 2, 2 power 15, 3 power 6, 5 power 6. Now add the plus 1 to each power. This is 16, 784. Powers plus 1. Why we are adding that? The concept is if you take the 2 power 5, okay, so all the powers, I mean the 2 power 5 factors are what? You take individual factors. For 2 power 5 means that 32. Suppose if you take that. What are the factors of these numbers? Suppose if I take the simple number, for example, it is written in the form of 3 cube into 3 square. For example, you take 2 cube value. Okay. So now you take this number. This number is divisible by which number? 2 cube means that 8. 8 is divisible by which numbers? 1. It is divisible by 2. It is divisible by 4. It is divisible by 8. Right? Which means that this is 2 power 0, 2 power 1, 2 power 2, 2 cube. Okay, so even if you take 3 square value is 9. 9 means that 1, 3, 9. So this number can be written as 3 power 0, 3 power 1, 3 square. Right? So actually the power is 3. So which means that we take that 2 power 1, 2 power 2, 2 power 3. Apart from that we also take 2 power 0. So here again that 3 power 1, 3 power 2. Apart from that power 0 is taken. So every time apart from the main numbers from 1 to that number, we are also including 0. So 0 means that we need to add plus 1. That is the reason why we are adding it. In every number we are considering it. So this is finding out the number of factors. Next, finding out the even factors. Next one. So out of the numbers, so some factors are even numbers and some factors are odd numbers, right? So sometimes the question would be asked like how many even factors are there for a number. Okay, for example, if I take the same example like 520. So as usual, you first write the number as a product of prime number. Suppose if I am finding out the total number of even factors for the numbers. So 520 means that what is the number? How do we write this? This is, we already wrote this one like 2 cube into 5 power 1 into 13 power 1. Okay. So to find out the number of factors, we add plus 1 to each power. So when you are finding out the even factors, so you take the power of 3 directly. Okay, so power of 2 directly. So 2 power will be taken directly because so even number into any number is even number. So that's why we don't consider 1 there. So 2 power 0 value is don't consider. So that's why. So when you are finding out the even factors, you take the power of 2 directly. So without adding anything, you take the power of 2 directly. What is the power of 2 here? 3. And for the rest of the numbers, you can add plus 1. Same procedure. 1 plus 1 is what? 2. 1 plus 1 is what? So finally 3 2s are 6, 6 2s are 12. See, there are total factors 16. Out of 16 factors, 12 are even factors. So it's very simple. Again, you first write the given number as a product of prime numbers. And after that, so instead of adding each power plus 1, so you take the power of 2 directly without adding anything. Okay. So power of 2 directly, and for the rest of the numbers add plus 1. Same like the previous one. Okay. Okay. If it is over, find out the total number of even factors for 640. Right, almost all in this concept we write every number as a product of prime numbers. For most of the concepts we use this method, like writing the number as a product of prime numbers. Actually you can write that, so 64 into 10, 64 means that 2 power 6 directly into 2 into 5, which means that 2 power 7 into 5. Okay, so 640 means that after you write this number as a product of prime numbers, okay, so 2 power 7 into 5. Okay, so you can use multiple methods like either directly divide with prime numbers, or else so you can break the number 64 into 10, then you can break those numbers. So 2 power 7 into 5 power 1. Okay, so even factors means that what is the rule for even factors? Take the power of 2 directly. So what is the power of 2? 7, and for the rest of the numbers add plus 1. For the rest of the numbers for the powers you add plus 1. 1 plus 1 is what? 2. So what is the power of 2? 7. And this number is 5 power 1. Add plus 1. 1 plus 1 is 2. 7 into 2 is what? 14. There are total 14 even factors. A little difference is only we are taking the 2 power directly. Okay. And similarly, if you look at the odd factors. So one thing is, so from the total factors we can subtract the even factors. Otherwise, we can directly do the problem. Suppose again if I take the number 520. So as usual, you first write the number as a product of prime numbers. What is that? 2 cube into 5 power 1 into 13 power 1. Odd factors mean now, so odd factors, odd number will be get only when you multiply odd numbers any number of times. In the complete product, even if you have one time even number, the final product would be even number only. So that's why when we want to get the odd number, the numbers must be odd numbers only. Okay. So when you are finding out the odd factors, don't take the 2 power. Okay. So don't take the 2 power. So you just remove the 2 power, and for the rest of the prime numbers add plus 1. So what are the rest of the numbers? 5 power 1 into 13 power 1. So add plus 1 to the power. 1 plus 1 is what? 2. Again 1 plus 1 is what? 2. 2 into 2 means that 4 odd factors. Okay. So total 3 things like total factors. Total factors means that what? Add plus 1 to each power. Next one, total even factors. Even factors means that what? You take the 2 power directly. Okay. Next, odd powers means that don't take the 2 power. So first you write it, I'll give you the complete example. 2 power 4 into 10. 10 is not a prime number. Again, you need to write the 2 power 5 into 5. So, but when you are finding out the odd factors, you don't consider the 2 powers. Even numbers, you write directly. So, I'll show you. Suppose when I give you a number in this way, so as you all know that, so the first of all, we need to write the number as a product of prime numbers. Let's take some number. So, this is a number. Okay, so we wrote the number in the prime numbers product. So when you are writing the total factors means that add plus 1 to each power. So 5 plus 1, 6, 4 plus 1, 5, so 3 plus 1, 4, 1 plus 1, 2. Okay, so 6 5 is a 30, 34 is a 120, 120 into 2 is what? 240. Total factors. Okay, now if you find out the even factors, when you are finding out the even factors, you take the power of 2 directly. So what is the power of 2? 5. So you write that number only. So the rest of the numbers will be added. 1 should be added. So 4 plus 1 is what? 5. So 3 plus 1 is what? 4. 1 plus 1 is what? 2. Okay. So what is the answer? 200. Okay. And now when you are finding out the odd factors, don't consider the 2 powers. Okay, don't take the 2 powers. For the rest of the prime numbers, add plus 1 to the each power, right? Which means that what? 4 plus 1, 5, 3 plus 1, 4, 1 plus 1 is what? So what is the answer? 40. This is how we find out the total factors, even factors and odd factors. I'll give you two important numbers. These 2 numbers are very important. Of course, when you see those numbers, immediately we may thought that those numbers are prime numbers, but that's not the prime numbers. But these 2 numbers are very, very important and we need to by heart them directly. So the one number is 1001. So tell me how many factors are there for 1001? Okay, so we have already learned that divisibility rules, right? So one of the divisibility rules applicable for this one, 11, yes. So what is that 11 divisibility rule? So alternative digits, 1 plus 0, 1 plus 0. Which means that 1 and 1. Difference is what? So which means that obviously this 1001 is what? Divisible by 11. 11 9s are 99. 1 is the remainder. 1. 91 is divisible by which number? 91 again it is not a prime number. I told you so. Number of times I will tell you and I told you that. I am telling you that. So the most important thing in your preparation of quantitative aptitude is tables. You need to be very good at tables. 91, how do you break it? 7. 13 7s are 91. I know that at this age learning tables is very difficult one. Okay, 7, 13, 11. These 3 are prime numbers. So 1001 is one of the most important numbers which we frequently see it in the different exams. Okay, including with UPSC. So 1001 number. Okay, it's a very important number. We use it very commonly. So when you see this number 1001, so it will be useful in multiple cases, multiple models, multiple problems. So whenever you see this 1001, first of all, it is not a prime number. And the next point is, so immediately you should remember that this number is written in the form of, written in the prime number product of 7 into 11 into 13. And actually, so you don't need to by heart it, it's simply logically you can remember it. So 1001 can be written as prime numbers product. Starting from 7, 3 consecutive prime numbers product. Starting from 7, what are the 3 consecutive prime numbers after 7? 7, 11, 13. So immediately we can write that 7, 11, 13. This is one of the most important numbers. So we need to by heart this number. So 1001, which is written in the form of what? 7 into 11 into 13. And there is one more number, that is 1729. Can you break this number as a product of prime numbers? Again, it is not a prime number. This number has a significant history in mathematics. Yes, it is Ramanujan number, 1729. Again, it divide with 7. Divide with 7. It is again written, can be written in the form of 3 numbers product. Actually, this can be written again as a product of 3 different prime numbers. I told you one number, that is 7. You tell me the remaining number. So the 3 numbers are 7, 13, 19. Yes, 7 into 13 into 19. And you must by heart these 2 numbers, because these 2 are very important numbers. 1729 is one number. Again, it is for both the numbers, 7 is a common prime number. So this number is the 3 consecutive prime numbers product, 7 into 11 into 13, 3 consecutive prime numbers product. And when it comes to this number, again, so for both the numbers, you remember the number 7, prime number 7. This is a product of 3 consecutive prime numbers, 7 into 11 into 13. Coming to the next one, so again starting from 7, it is a product of 3 alternative prime numbers. Alternative prime numbers means that 7, what is the next prime number? 11. You skip that one, 13. And after 13, what is the next prime number? 17. If you skip that number, 19. Okay. So these 2 numbers, you remember it. Okay, this is how we find out the number of factors and number of even factors and number of odd factors. This one. So the number of factors means that what? Suppose if you find out the number of factors, you see that suppose if I take that 1001, so we wrote this number as 7 into 11 into 13. So number of factors mean that, as usual, power is what? 1. So 1 plus 1 is what? 2. Again 1 plus 1, 2. 1 plus 1 is what? 2. So 2 into 2 into 2 is what? 8. Next, number of even factors means, what is the condition for the number of even factors? Number of even factors. 2 power must be taken directly. But there is no 2 here. When there is no 2, then the answer is 0, which means that there are no even factors at all. So the number of even factors is what? 0. So when you find out the number of even factors, there must be 2 power. Okay. In this product, we don't see any 2, right? Which means that there are no even numbers. So the number of even factors are what? 0. Next, you take the number of odd factors. Same, except 2 powers. So you take the powers, add plus 1 to the each power, the remaining numbers, which means that same number of odd factors, 8. Same like the, for that also you will get the same answer. Number of odd factors condition is what? Except 2 power, so you take the powers of the remaining prime numbers. So 2 is anyway not there, so remaining all are the odd numbers only. So add plus 1 to each power, 1 plus 1, 2, 1 plus 1, 2, 1 plus 1, 2. For everybody the answer is same. So 2 power 5 into, you got 5 power 1, right? Total factors means that 5 plus 1, 6, 1 plus 1, 2. Even numbers means that you take the power of even 2 power directly, that is 5. 1 plus 1 is 2. 5 into 2 is 10. 640, I think that that's 2 power 7. I think it's 2 power 7 into 5. Okay, let's go to the next application of even numbers, factors. Okay, now you write this question. Do you understand the problem? Okay, let's take a simple example first. So in how many different, suppose when I say that instead of 520, so let me take an example for this one. So a simple number. In how many different ways 24 can be written as a product of 2 different numbers? So 24 can be written as a product of 2 different numbers. How do you write that? 24 as a product of 2 different numbers. So which means that 24 can be written as what? 1 into 24. So this is a product of 2 numbers. And next, we can also write it as 2 12s, and we can also write it as 3 8s. We can also write this number as 4 6. Okay, is there any other way? Only this. So again 6 into 4, 4 into 6, only one way. So which means that how many ways are there? 4 ways. Okay. So likewise, suppose if you write 520 as a product of different numbers, in how many ways we can write that number? 520. So it can be 520 or it can be 5200, any number can be given to us. So how do you find out? You observe this pattern of these numbers clearly, carefully. What are these numbers? 1, 24, 2, 12, 3, 8, 4 and 6 for 24? Factors only. So this 1, 2, 3, 4, 6, 8, 12, 24. These are the factors of this number 24. Okay. So which means that if you see, just think logically that when you write any number as a product of different number, obviously when those numbers are factors, then only we can able to write it. So in other words, yes, number of factors divided by 2. Because from two numbers we write one way. So this is one way and this is another way and this is another way. We take it. This is another way. Right? So from two factors we write that one way. So from two factors we write one way. So it is nothing but the concept of number of factors only. So the problem is whenever it is given that in how many different ways we can write a number as a product of two different numbers. So it is nothing but, in other words, it is nothing but number of factors divided by 2. A number of factors divided by 2. Okay. So it is also very important. It was asked once in the previous year papers. A number is given to you, so and it was asked like in how many different ways, so this number can be written as a product of two different numbers. So you know how to find out the number of factors, right? The same thing. So the question is, if the in how many different ways the number can be written as a product of two different numbers, means that first find out the total number of factors, then divide with 2. So tell me the answer. 520. Okay, so now I'll use it. So you can write like 13 into 40, so on that way, or otherwise you can divide with any prime number. If you don't know the values of prime numbers, then you can divide like this. Okay, so directly so you can divide with any prime number. Okay, so that's why you write that at least 1 to 50 prime numbers. 1 to 100 is good, so at least you remember that prime numbers from 1 to 50. So 13 tens and 2 5s, which means that 520 can be written as what? So how many 2s are there? 3. So 2 cube into 5 power 1 into 13 power 1. So number of factors means that what? 3 plus 1 is 4. 1 plus 1, 2. 1 plus 1, 2. So divided by 2. So how many ways? 520 can be written as a product of two different numbers in 8 ways. Okay. So just that is simply like total number of factors divided by 2. Now you write for this one. In how many different ways that 4500 can be written as a product of two different numbers? 4500. You require practice for quantitative aptitude, for CSAT. You have to take it very seriously, CSAT paper. It's all about your practice. 8 ways. So 4500. So you can write it immediately 45 into 100, right? 45 means that, what is the immediate idea comes to your mind? So 45 means that 5 into 9. Okay, so 5 is a prime number, no problem, but 9 is not a prime number. How do you write 9? 3 square. Yes. Then tell me that 100 can be written as what? 10 into 10. Okay, so whatever the number you tell me, so I'll write it. 10 into 10. Okay, 10 means that prime numbers product. 2 into 5, 2 into 5. So here 2 is written for 2 times, so 2 square. 3 is for 2 times. 5 is for how many times? 3 times into 5 cube. Okay. So now what is the answer? Number of factors divided by 2. Number of factors means that what? 2 plus 1, 3. 2 plus 1, 3. 3 plus 1 means that 4. Divided by 2. Okay. Simply you know that how do you find out the number of factors? And then divide with 2. Okay. So 3 3s are 9, 9 2s are 18. Okay. 18 ways. Number of factors divided by 2. Okay. So now I'll change the number. So 3600. How many ways means that 2.5 ways, 3.5 ways, 22 ways. We can't say that 22.5 ways. Either we can say that, we always say that whether it can be 22 ways or 23 ways or 24 ways, but we never say that 22.5 ways. Right, when the question is given in this way, so first, see, I'm taking a number 36. First all of you look at this. So 36, suppose if I take an example 36, I'll write all the possible ways that. So 36 means that how can we write that? 1 into 36. Next number 2 into 18. So next number 3 into 12. So next number 4 into 9. Next number, yes, 6 into 6. So when you are writing the number of factors, you write 1, 2, 3, 4, 6, 9, 12, 18, 36. You can't write 6 two times because the same number only, right? So why we are not getting the answer exactly? Because so here the same number is repeated. So this will happen only for perfect square numbers. Okay, for any other number, if it is non-perfect square, you will get the answer exactly. Only if it is a perfect square, then we don't get the exact value because it is not perfectly divisible by 2. Then the question would be asked in two different ways. One is can be written as a product of two different numbers, or 3600 can be written as two numbers, as a product of two numbers. Okay, so what is the difference actually? So these two questions are different. Suppose if you take this 36 we write 1 into 36, 2 into 18, 3 into 12, 4 into 9 and then 6 into 6. Suppose if so let's see that the difference between these two questions. The first question is what? Can be written as a product of two different numbers. Second question is what? 3600 can be written as product of two numbers. Here suppose if I take this one, this condition as a product of two different numbers means that, so how many ways I have? So I can take that 1 and 36, these two numbers are different numbers, 2 and 18, again 3 and 12, so different numbers, 4 and 9. So we'll consider this also, this also. If I am finding out these two different numbers, can I take this one? 6 into 6. The question is can be written as a product of two different numbers, which means that these two numbers must be different. Then how many ways we get? Only 4 ways. Okay. So here we don't consider this one because these two numbers are same, but the problem is asked for two different numbers. So which means that how many ways are there? Only 4 ways. Now coming to the second case, 3600 can be written as a product of two numbers means that those two numbers can be same numbers or different numbers, right? The product of two numbers mean that, so product of two numbers means that it can be the two numbers are same numbers or two numbers are different numbers. Then the answer is what? 5 ways. So that's why when the problem is asked for this one, the formula is number of factors minus 1 by 2. Number of factors minus 1 by 2. And this condition is only if the given number is a perfect square. PS means that perfect square. If the given number is a perfect square, then there are two conditions. The first condition is the number can be written as a product of two different numbers. Then the formula we use it what? Number of factors minus 1 by 2. Okay. Number of factors minus 1 by 2, or else can be written as a product of any two numbers, then the concept is what? Number of factors plus 1 by 2. Different numbers means that minus 1 by 2. Any two numbers means that number of factors plus 1 by 2. Is it clear? So that's why you need to carefully look at the problem when the given problem is perfect square. If it is not a perfect square, so we'll get the answer exactly. Okay, the question arises. So you first find out the number of factors and then immediately you divide the number with 2. If you get the exact answer, no problem. So we directly choose that option. Otherwise, if you are not getting the exact answer, which means that if you get the answer in decimal points, then immediately, so you need to think that that number is what? A perfect square. That number is a perfect square. Then immediately there are two conditions. What are the two conditions? One is the question can be asked as a product of two different numbers, or else it can be written as a product of any two numbers. Okay. So different numbers means that number of factors minus 1 by 2. So same means that number of factors plus 1 by 2. Okay. But you always need to be very careful when you are doing the perfect square numbers. So slightly difference is there. Only slight difference. Now you find out the answer for the first case and the second case. 22, 23 second case. Find out the values. 3600. So this is the first case and this is the second case. As usual, first write that number as a product of prime numbers. So 3600 as a product of two different numbers. So 36 into 100. So 36, now you tell me, how do you write 36? Any number, any two numbers. 6, okay. And then 6 means that it is not a prime number. So 2 into 3, 2 into 3. Can I write it directly 2 square into 3 square? So 2 square into 3 square. Because it is written 2 into 2, 2 into 3, 2 into 3. So 100 means that 25 into 4, your choice, or 10 into 10, which means that 2 into 5, 2 into 5. So which means 2 square into 5 square. So final value 2 square means that what? 2 power 4. So 3 square. So 2 power 4 into 3 square into 5 square. So now we'll take the first condition. The first condition is what? So anyways, first find out the number of factors, means that what? Add plus 1 to each power. 4 plus 1 is what? 5. 2 plus 1, 3. 2 plus 1, 3. 45. First condition, product of two different numbers. Product of two different numbers means that number of factors minus 1 by 2, right? Number of factors means that what? 45 minus 1 by 2. 44 by 2 is how much? 22 ways. So next, product of two numbers, which means that what? Plus 1 by 2. So 45 plus 1 by 2. 46 by 2 is 23 ways. That is 22 ways, 23 ways.